All right, guys, welcome to the first of our kind of physics videos. I'm making these videos to be able to show you. The way I teach physics is there's a lot less notes than in, say, like biology or even chemistry. It's a lot of examples, So like the notebooks are that I've put together. If you read through the first one that's out there, you'll see it actually has most of the explanations and stuff already in it, other than a few small details. Like if you did the notes like I asked you to, you'll notice there wasn't a ton to write down for this first set. The reason is most of my notes in physics are myself doing examples, which is a really hard thing to do online. So I found a way that I can record myself kind of writing and working through problems, so you guys can watch me do it, follow along in your books, and then later on, if you're confused on something, you can always rewatch the video. If anything I'm saying doesn't make sense today, that's totally fine. You can just go back and watch the video again, and I will provide kind of a question and answer period in the coming days for you to ask specific questions to me that are things you really don't understand. All right. This first part of physics is what I call pre-physics. It's actually not any new information or not anything that's actually physics so much as it is how to do certain things in math with physics. So the first little bit here is going to seem very math heavy. So please just try your best to follow along. Please save questions that you have for when I have little online tutorials for you guys. That'll be best time to ask. So today, this first lesson is all about converting units, which I know you guys did in math, but we have a specific way of converting units in science, which I actually have taught you already back in chemistry. It's through unit analysis, all right? I find students don't really like unit analysis, and I'm sorry about that, but if you want to take chemistry 20 or even physics 20, most of the unit conversions and the ways formulas have come about are done through unit analysis. And if you don't understand unit analysis, it's going to become trickier and trickier. So if you like converting units the way you did in math, which I think was mostly cross multiplication, feel free to do that. But as we get further and further in physics, you're going to want to start using unit analysis more and more and more. All unit analysis is a way to convert from one unit to another by looking at the ratio between those two units. Basically, like how do those two units relate to one another? In other words, what we're trying to find out is how many of the small unit fit into one of the large unit, all right? So we call that our unit conversion factor. And again, it's just how many of the small unit fit into one of the big unit, all right? This first example is really easy, and it's not in your book. I just kind of want you to watch me do it, all right? So in this first example, we're going to convert 534 meters into kilometers. To do that, we first have to find our unit conversion factor, which again, how many meters fit into 1 kilometer. Now you guys should know that there are 1,000 meters in 1 kilometer, or another way of phrasing this is that 1 kilometer is made up of 1,000 meters. Okay, so these are two setups of saying the same thing. Both of these say exactly the same thing, that there are 1,000 meters in a kilometer, or a kilometer is 1,000 meters. But mathematically, they're different just because of the fact that kilometers are on top here and on the bottom here. All right, and that changes how we do things. Whenever we use unit analysis, we always want to take what we were given in the problem and multiply it by one of these two conversion factors. We just have to figure out which one, and there's a really easy way to do that. All right, so we're given in the question 534 meters, and I want to multiply by one of these two, okay? And I just have to pick which one. The way that we decide is by looking at where the units fall in both converting factors, all right? So in the question, I'm given meters, and I want to get rid of meters. I want to turn it into kilometers. So what that means is I want meters to be below this line on here, okay, which doesn't make a ton of sense right now, but if you let me go through it. So here we're going to use this guy here because meters is on the bottom, all right? So we're going to multiply by 1 kilometer over 1,000 meters. And the reason we do this is we want meters to cancel out. And if you look here, what I'm going to do when I do the math is I'm going to go 534 times 1 divide by 1,000. And what I'm really doing is I'm multiplying by meters here, and then I'm dividing by meters here. And what that does is it gets meters to cancel out, and then the only unit I'm left with is kilometers, which is the unit that I want, all right? So mathematically, I'm going to go 534 times 1 divided by 1,000, all right? And so when I multiply that out, my answer is going to be 0.534 kilometers. All right, run out of room there, but that's how this works. So the basics of how to do any unit analysis question is take what you're given in the question, figure out how the two units relate to one another, and we call that the unit conversion factor. Take what you're given in the question and multiply it by whichever setup gets rid of the unit you don't want anymore. Okay, so you're always looking to put the unit you're getting rid of on the bottom or on the opposite side of the line. That way we're multiplying by it and then dividing by it, which effectively makes meters go away. All right. So that's the first example. Let's get into some of the ones in your book. So we are on page 3 of your book, if you're not sure. So this is the first, it's not the first question you guys have, but it's one of the easier ones. The other ones are a little bit trickier, so I wanted to start with this one. So in this one, we're going to convert 34 seconds into minutes, okay? As always, the first thing we have to do is figure out how our units relate to one another. What is our unit conversion factor between seconds and minutes, all right? So what we're going to do is say, okay, how many of the small unit seconds fit into one of the big unit minutes? And you guys should know, hopefully, that there are 60 seconds in 1 minute. Or there is 1 minute is made up of 60 seconds, okay? Now we're going to take what we were given in the question, 34 seconds, and we're going to multiply it by one of those two setups. Okay, oh, geez. Let's change that line. I don't like that. All right. So basically what we want to do here is say, okay, do I want to multiply by the one on the left or on the one on the right? Okay. The way we can figure that out is we want to get rid of seconds, okay, which means I want seconds to be below this line here, right? Because then I'm multiplying by seconds and then dividing by it. So I want to use this setup here. So we're going to have our 1 minute on top and 60 seconds on the bottom. So we're going to go 34 times 1 divided by 60. What that does is it makes our seconds cancel out and we're left with minutes, which is what we want. All right. So I'm going to go 34 times 1 divided by 60. And if you throw that in your calculator as an answer, you get 0.57 minutes, which makes sense because 34 is a little over half of a minute. So this is 0.57 of a minute. All right. All right. So those are two easy examples. We're going to get to some harder ones. So I just want to take a second to kind of summarize what we said. So whenever you are trying to solve or trying to convert one unit to another, your first step is to always find the unit conversion factor. How many of the small units fit into just one of the large units? Then multiply the given number in the question by the unit conversion factor with the right configuration so that the unit we're trying to get rid of cancels out. In other words, you want that unit on opposite sides of that line. You want it above the line and below the line. And then record your answer and make sure you have the right units. All right, but we're going to get into some trickier ones now. So please bear with me. I know this next part's going to be a little bit weird. All right. So here, this is a table that starts to show all of the different units in the metric system. You guys should have learned a little bit about this back in math, but the idea in the metric system is that we have kind of our base units, which are all kind of on this line here, okay? These base units could be meters. Oops, wrong thing. These could be meters, they could be liters, or they could be grams. Okay? It doesn't matter which one we're using, the same system applies. And then what we have is different prefixes in front of them to tell us how many meters or how many liters or how many grams we're talking about. So a kilometer, as we've already said, kilo is 1,000, it means a kilometer is made of 1,000 meters. A kiloliter is made of 1,000 liters. Okay? On the other end down here, we get smaller than our units. So if I have a centimeter, that's 1/100th of a meter, as an example. This chart looks really confusing, and I understand that. But for the most part, we're only going to be working in this range here, from kilo down to milli, okay? These little guys down here, we don't care about. I don't even care about micrometers, and I don't care about all these big ones up here. So what I care about is you understand the difference between a millimeter, centimeter, decimeter, etc., etc. All right? You guys have this chart in your formula or your data booklet. It's on the first page of your data booklet. It looks a little bit different than mine. Mine's a little more complex, but it's the same basic idea. And what you guys should know about the metric system is that every time I move up from one unit to another, whenever I move from one prefix to another one, we're always going up by 10 times, which means that a decameter is 10 times bigger than a meter. A hectometer is 100 times bigger. And every time I go up here, I multiply by 10. So if I started here, this is 10 times bigger. This is 10 times bigger than that. 10 times bigger than that. That'll be important for us when we're trying to figure out our unit conversion factors, because we always want to figure out like something like maybe how many centimeters are in a kilometer. And this chart lets us do that. All right. I know that sounds a little confusing, so let's start putting an example to it. All right, so we're going to take another example from your book. This time, it's a little bit, the units are a little bit trickier, all right? Because we're trying to convert milliliters to kiloliters. And unlike the other examples where we kind of knew that there's 1,000 meters in a kilometer and that there's 60 seconds in a minute, we don't necessarily know off the top of our heads how many milliliters are in a kiloliter. So we can use this chart to figure that out, all right? So what we're going to do is use our chart here to figure out how many milliliters are in a kiloliter. And the way we do that is by finding milli, the prefix here, on the chart. Milli is down here, okay? We're going to kind of use this as our base starting point, all right? And we're going to treat this, I know it says 0.001 here, don't stress about that. We're going to treat this as 1 right now because we're going to see how many times bigger a kilometer is, all right? So what we're going to do is we're trying to go from millimeters to kilometers, or kiloliters, sorry. So what we're going to do is we're going to climb up here, and every time we go up, we're going to multiply by 10, okay? So I'm saying right now that this is worth 1, okay? Because that's the unit we're starting at. From there, centimeters are 10 times bigger. Decimeters are then 100 times bigger. A meter, or liter, is 1,000 times bigger. A decameter is 10,000 times bigger. A hectoliter is 100,000 times bigger. And that means that a kilometer is, or kiloliter, I keep saying meter, a kiloliter is 1,000,000 times bigger. And so if you notice, all I did there was every time I went up here, I just multiplied by 10. So 1, 10, 100, 1,000, 10,000, 100,000, 1,000,000. And that's how we get that unit conversion factor, all right? So we now know, and I'm just going to move this out of the way and clear these guys off here. We now know that our unit conversion factor is that there are 1,000,000 milliliters in 1 kiloliter. Or, another way of writing that is saying that 1 kiloliter is made up of 1,000,000 milliliters. Okay, these are our 2 unit conversion factors. Now that we have that, we're going to solve this exactly the same way we solved all the other 2 questions. All right, so in the problem, I'm given 500 milliliters, and I want to multiply that by one of these 2 setups. We just have to figure out which one, and the way we decide, as always, is we're trying to get rid of milliliters, which means we want milliliters to be on the opposite side of this line. So I want to use this setup over here. Okay, so we're going to have our kiloliters on top and our 1,000,000 milliliters on the bottom. Okay, so now, just like before, I'm going to multiply all this out. The milliliters will cancel because I'm multiplying by milliliters, then dividing by it. So I'm going to go 500 times 1 divided by 1,000,000. And if you put that in your calculator, what you get as an answer is 0.0005 kiloliters. There we go. Okay. So again, all I did was 500 times 1 divided by 1,000,000 to get this answer down here. Okay. We're going to do another tougher example. So again, this time, this one's in your book as well. This time we're going to try and convert from decameters into decimeters, okay? So as per before, we're going to make sure that we figure out how many decimeters are in 1 decameter, because decimeter is our smallest one, decameter is a little bit bigger. And we can use this chart to do that. Or you can use the chart in your data booklet, all right? So to do that, here's decimeters down here. And we're just going to count upwards until we hit decameter. We're going to count this as 1, because that's our starting jumping off spot, okay? A meter would be 10 times bigger than that, which means that a decameter is 100 times bigger. So as I jump up here, again, I'm just multiplying by 1, then 10, then 100. We're just going up by 10 each time. So that means that my unit conversion factor is going to be that there is 100 decimeters in 1 decameter, or 1 decameter is made up of 100 decimeters. Okay, again, saying the same thing. Those are our 2 unit conversion factors. In the problem, we're told that there's 34 decameters that we want to convert. So we just have to figure out which setup we want to multiply by. As per before, every time I'm trying to get rid of this, which means I want decameters to show up on the bottom here so that it's on opposite sides of this line. Okay, so I'm going to have my 100 decimeters on top and my 1 decameter on the bottom, which will get my decameters to cancel out. When I multiply this, I'm going to go 34 times 100, which is 3,400 decimeters. Okay. Again, the only problem here is trying to come up with what the unit conversion factor is, and that chart will help you as long as you count upwards as you use that chart. All right, just to come up with this. Once we've got this, we're fine. All right, next one. All right, this will be the last example we do today, which is nice, and this one's also in your book. This one's a nice, easy one. We don't need that chart for this. We just need to know how many seconds there are in an hour, which you may not know off the top of your head, but at the bottom of the page 1 of your data booklet, it does tell you how many seconds there are in an hour, or you could figure it out. We know that there's 60 seconds in a minute, and there's 60 minutes in an hour, so all we have to do is multiply 60 times 60, and when we do that, we find that 1 hour is made up of 3,600 seconds, or 3,600 seconds make up 1 hour. All right, so now we're going to take what we were given in the problem, the 4.2 hours, okay, and we're going to multiply that by one of these two setups. Hopefully you're getting the hang of this by now. We want to get rid of hours. We want hours to show up at the bottom, so we're going to want to use this setup. All right, so we're going to multiply by 3,600 seconds per 1 hour. The hours will cancel out. And when I multiply those two things together, I multiply 4.2 times 3,600 divided by 1, I get 15,120 seconds. All right? That was a nice, easy one. We didn't need to use that chart to come up with our unit conversion factor. We could just look this up in our book or figure out how many seconds there are in an hour. This is a conversion we'll have to do a lot, is between seconds and hours. So you're going to want to know that 3,600 number, but it's easy enough to figure out on your own. So that's it for this lesson. I hope this went okay. I don't know. Please give me some feedback on the videos, things I can improve. It's a little weird to talk to my iPad in the middle of my basement, but that's what we're doing. For practice, what I'd like you guys to do is try and finish the 2 questions at the bottom of page 3 of the note booklet, and then there's conversions on page 4. Those ones where you have to use that chart to come up with a unit conversion factor, I know they're harder. If you're really struggling with them, I wouldn't stress about it too much, okay? For the most part, the only 2 units we really switch a lot or convert a lot in physics are from hours to seconds and from kilometers to meters. So if you can do those 2, you're doing pretty well. If you can't convert from like a decameter to a hectometer, it's not the end of the world, but I do want you guys to try and play around with this and figure it out. The answers are up on D2L, and once you get that chart on page 4 done, you're doing really well. If you have questions, I will have a I'll have a virtual classroom for you guys to come and ask. But for now, try and work through this. Talk to your friends, whatever you guys need to do to get this figured out. All right, have a great day, guys.